This is video number 2 of the problem, what's the probability of getting 4 of the 6 possible numbers when 6 dice are rolled? We started off from the very beginning by looking at a coin flip, then 2 coin flips, and now we're going to look at something else to build our foundational understanding of the concept of probability. 2 dice are rolled, the result is a 10. That's given. 6 and 4 is one possibility. 5 and 5 is another possibility. Those are the only 2 possible combinations. There's no 7s. Got to be a 6 or 4 or a 5 and 5. What's the probability that a 10 consists of 2 5s? This is a deep conceptual problem. Took a long time for humans to wrap their heads around. Well, how many different ways are there to get a 10? That's the key question. If you roll 2 dice, how many different ways are there to get a 10? Well, let's simplify again and go backwards. How many possible rolls are there? With 1 die, there's 6 possibilities. That's pretty clear. What about with 2? Well, the first die has 6 possibilities. The second die has 6 possibilities. Seems like with 2, there has to be 36. And here they are. When the red die is a 1, the blue die can be anything from 1 through 6. This is a completely exhaustive list of all the possible outcomes when 2 dice are rolled. Now we have to find the 10s. How many of the 36 are 10s? Here's one right here. The red is a 4, the blue is a 6. Here's one here. They're both 5s. Here's one, a red 6 and a blue 4. Those are the only ones. The probability of rolling a 10 is 3 out of 36. 3 out of the 36 rolls are 10s. And when it is a 10, the probability of 2 5s is 1/3. This is very hard to see when you're looking at 2 white dice that are identical. Come on, it's 6 4, 5 5. There's only 2 possibilities. But in actuality, the probability of 2 5s, if it's a 10, is 1/3. And if you go to the casino, the roll of 2 5s is called 10 the hard way. It's a hard 10. Because it's harder to get 2 5s than a 6 and a 4. Because there's 2 ways the 6 and the 4 can be. It can be 4 6 or 6 4. Very challenging concept to understand. You should invest a lot of time in understanding this concept fundamentally. Now let's take another step forward. We did coins. We did 2 dice. Now we're doing 3 dice. Red, green, and blue. How many different rolls are there? The red has 6 possibilities. The green has 6 possibilities. The blue has 6 possibilities. 6 times 6 times 6 is 216. And let's look at them. There they are. The upper left corner has a 1 1 1. The bottom right corner has a 6 6 6. And every single possible roll is in here. And the probability of each one of them is 1 out of 216. Here's a question. In how many of these rolls is red the highest, blue the second highest, and green the lowest? There can't be any ties. The red has to be the highest, the blue has to be second highest, and the green has to be lowest. Let's find them. Let me see. 6 5 4. Here's one. The red is 6, the blue is 5, the green is 4. 6 5 3, 6 5 2, 6 5 1. Those all work. That's 4. Next row up, we have a 6 4 3. 6 4 2, 6 4 1. That's 3 more. Then we have 6 3 2, 6 3 1. Then we have 6 2 1. That's a total of 10. That exhausts all the possibilities when the red die is a 6. Now let's go to the 5. Here's 5 4 3. There's 1. 5 4 2, 5 4 1. That's 3. Then we have 5 3 2, 5 3 1. Then we have 5 2 1. That's 6 more. That's a total of 16. Let me see. 4 4 3 2. There's 1. 431, that's another one. 421, that's another one. 3 more, that's 19. And it turns out there's only one more. It's 321 right here. So that's 20 different rolls out of the 216. And what that means is the probability of it occurring is 20 out of 216. This is the fundamental concept of probability. And this is what's important to understand, not some equation for combinations or permutations. So the fundamental concept of probability when rolling dice, the probability of a particular result is the number of ways it can happen divided by the total number of possible rolls. This is not a rule to remember. It's a concept to understand. Don't commit it to memory. Understand it. Then you won't have to remember it. So now let's move forward. Let's consider the probability of n different numbers when rolling 3 dice. What are the possible quantities of the 6? We only have 3 dice. So the most different numbers you can get is 3. Then you can get 2 different numbers. For example, 113, that's 2 different numbers. And you can also get all the same number, 222, for example. So we're going to tackle this problem with the scheme of whether a number that's rolled is new or a repeat of a number that has already been rolled. We're going to roll the dice one at a time. Is it new? Is it a repeat? That's it. That's our scheme. How do we get a triple? What is the NR scheme for a triple when we roll dice one at a time? Well, the first one has to be new. You can't roll the first die and get a number that's already been rolled. Next 2 have to be repeats. A 3, then you have to get a 3, then you have to get a 3. First number can be anything. How many different ways can that happen? Well, the first die can be any of 6. The next die has to repeat the first one. The third die has to repeat the first one. Well, if we multiply these out, we get 6. And we know there's 6 because there's 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4, 5, 5, 5, and 6, 6, 6. We know there's 6 triples in that table of 216. What about 3 singles? What is that in the NR scheme? 3 different numbers. The first one has to be new, the next one has to be new, and the third one has to be new. New, new, new. Those 3 different numbers. How many ways are there to do this? Well, 6 ways, 6 possibilities for the first number. Now the first number, you can't repeat it with the second number, so there's only 5 possibilities for the second number. And then the third number, there's only 4 possibilities left. So you multiply those out, there's 120 different rolls in which all the numbers are different. And we can find them in the table. What about a double and a single? This is a little bit more involved. And we recommend that you do it right now. Pause the video. Try to figure it out. You're not going to pause it, are you? All right, I'll keep going. It can be new, repeat, new. But it also can be new, new, repeat. There's 2 different ways to do it. New, repeat, new. How many different rolls are there? The first one's always 6 possibilities. Now the second one has to repeat the first one. The third one has to be new, and there's 5 new numbers available. So there's 30 of those different rolls. New, new, repeat. First number is a 6, then has to be a new one. There's 5 remaining numbers. Then the repeat can repeat either the first or the second. So there's 2 possibilities there. So there's 60 that are new, new, repeat. That's a total of 90. Here they are. The first 30, so 3 columns and 10 rows. 112, 113, 114, 115, 116, 221, 223, 224, 225, 226. These are all the possibilities in which the first 2 numbers match. New, repeat, new. There's 30 of those. Here we have new, new, repeat, but the repeat is a repeat of the first number. There's 30 of those. Here it's new, new, repeat, but the repeat is of the second number. A total of 90, and now we can review. There's 216 possible outcomes. We found 6 triples, 90 rolls in which there was a double and a single, and 120 rolls in which there were 3 singles. We can summarize the results, and if we add them up, we get 216, as we must, because we just separated that table into 3 bins, and we put all those rolls into one of 3 bins. One was all the same, one was a double and a single, and one was 3 singles. Next, we're going to tackle 4 dice, and that's the next video. Thanks for watching.